Hi there. So we've talked about net force and we've looked at, when I have forces, unbalanced forces. So in this case, say these two are 10 newtons and this is 10 newtons. So these cancel out. If I sum them, there's zero. But you see I have some net force moving in this direction. And if this was, say, 20 and 10, then I could find the net force by adding the 20 plus negative 10 to get a net force of 10 newtons to the right. But the question is, what happens if we're talking about a situation where the forces aren't in just the xy plane? So what if I had a force that was being applied like so? How would I find the net force? A case of this would be like if you were dragging a box across a surface by a rope that was attached at an angle. How could we figure out the force that's being applied in order to accelerate it? So the way that we do that is with they're called vector components. So remembering that forces are vectors, we can break it into components. And this goes back to our vector addition. So if you remember the vector addition, what we did is we took a vector, and if we put it head to tail, we ended up with a resultant vector, like so. I know my arrows are a little off, but you get the point. So what we do to get vector components is we kind of go backwards. So if I was given this vector, let's call it f, I can resolve it into its components of a right triangle. So these perpendicular vectors, and we call this f and the y, that's the y component, and the x component. And now I can treat these. Now I can add this to any other x force that's being applied in the x direction, and this one would be in the y direction. So when we analyze force diagrams, as they get more complicated, we'll end up doing everything kind of twice. We do one in the y direction, one in the x direction, to see what happens. So let's deal with this case. So let's say we're talking about this box that's being pulled. It's being pulled across, let's just say, a frictionless surface. So there's no friction being applied. We have some force here due to gravity. So we have the force of the earth on the box, and then we have the normal force of the surface on box. And then let's say that this is being applied at a 30-degree angle. So then the question is, here we'll have to give this some force. So we'll say that this is a 40 Newton force that's being applied at a 30-degree angle to the box. So then the question is, how much force is actually being applied in the x direction? So if I break out these two, if I add these, this is zero. So all I care about is the force in the x direction. There's going to be a y component that adds on to this, but we're not concerned about that. So we're just going to look at in the x direction. So the x direction. So breaking out this force diagram, what I have is I have a 40 Newton force being applied. And now let's break that into its components. So I end up with these two vectors. So here's my f in the x direction and my force in the y direction. And this was at 30 degrees. So this is why you needed to go over the trig, because now I just applied trig to find this missing value, this f in the x direction. So since this is my angle, I see that it's my adjacent and my hypotenuse, which is cosine. So I would say that the cosine of 30 degrees is equal to my force in the x, my x component, divided by 40. Multiplying here, you get 40 times cosine 30 degrees is my force in the x. And so I get my force in my x component of the force. It's going to be 34.64 newtons. So you can see a portion of it. We had 34 of it is being applied. And then you could do the same for the y to figure out how much is picking it up. But that's basically all there is to it. This is the key concept that you need to get. We need to break it up into x and y whenever it's not in the xy. So next video we'll do some more examples, and then you'll have some practice. And that's it.